Hello, everyone. Welcome to our first learning video of AWS Beatbox Essentials Tracks. Today, we will explore the functionalities of networking and EC2's capabilities at foundational level. In today's hands-on session, we are going to deploy an EC2 instance within VPC and showcase different integration and operational efficiency this configuration offers. Thank you for joining us on this journey of exploration and discovery. Let's dive in. So in today's hands-on session, we will create a virtual machine that is EC2 instance within a virtual private network and access this instance either via PuTTY or Session Manager. Before deep diving into creating EC2 instance, we need to create networking components, and the default ones available with account creation are not enough to host EC2 instance. Generally, we would create VPC in US East, one region in our case, followed by two public subnets in AZ1 and AZ2, with a public route table associated with Internet Gateway. In this setup, an EC2 instance is hosted within a public subnet, meaning it has direct access to the Internet. The public subnet is associated with a route table configured to send traffic destined for the Internet to an Internet Gateway, IGW. In this configuration, an EC2 instance resides within a private subnet, isolated from direct Internet access for security. The private subnet is linked to a route table directing outbound traffic to a network address translation NAT gateway. The NAT gateway facilitates Internet connectivity for instances within the private subnet by translating their private IP addresses to public ones, enabling them to access resources outside the private network while maintaining security. Thus, for learning purposes, we have built all these components and test respectively. Now our next step would be to create EC2 instance. Here we will create EC2 instance and access it via PuTTY with direct Internet access with public IP address. Another use case is that we can privately access our EC2 instance and access via Session Manager, which will require outbound traffic to a NAT gateway. Let's deep dive into hands-on session. In our hands-on session, first thing we will do is go to VPC. Make sure for this hands-on we are operating in US East, one region. Here in VPC console, you can click on your VPCs and you might see the default one that is created during account creation. We don't need to use this VPC and we'll create a new one. While creating a new VPC, we have now two options. We can create standalone VPC or create VPC along with other networking components such as subnets, route table, NAT gateways, and even IGW. Here we can give name tag associated with all components such as VPC, subnets, etc., and choose CIDR range, which is AWS IP ranges 192.168.0.0/16, and keep other parameters as default with number of AZs as 2 public and private subnets, and for now we can keep NAT gateway in 1 AZ and no VPC endpoints for now. So now we can visually see how all these components are associated and linked with each other before creating them to make sure we are creating the correct needed networking components. After verifying all the configuration, click on Create VPC. It generally takes few minutes to create all the required components, as components such as subnets, route tables, IGW are quickly created, as well as attaching IGW to VPC and associating route tables, but it takes few minutes for NAT gateway to be created. Now we can see all the required components are created, and we can go to VPC console to check them. Here we can see the demo VPC created with all the required public and private subnets in 2 AZs associated with their route tables and IGW and NAT gateways respectively. We can check the subnets that were created, such as private and public subnets in US East 1A and US East 1B AZs. In route tables, we have public and private route tables where each private route table is created for each private subnet and is associated with them respectively, whereas the public route table is common for all public subnets. Also, IGW is created that is attached with demo VPC and is associated with public route table. Next, we can see NAT gateway creation that is associated with public elastic IP address that can be used by private subnet to securely use Internet. After all the networking configuration is done, let us create EC2. Here on the EC2 console, we can click on Instances and then Launch Instance to create one. Here we can give any name we like for our EC2 instance, such as Demo, Public, EC2, and choose any free tier available operating system image, such as Linux 2 AMI, and for demo purpose we can keep T2 micro instance type, as it is also low-cost compute instance type. If you are looking to SSH via PuTTY, it is recommended to have key pair that will be used to authenticate into EC2 instance. You can create a new key pair with a unique name and make sure it is RSA pair type and is PM format. Make sure you keep its copy upon creation as it can't be downloaded later. If your networking settings correspond to default ones, do modify them to the ones you have recently created. You can do so by clicking on Edit button and choose Demo VPC, and for this public EC2, choose Public Subnet and enable Auto-Assign Public IP for this use case. In addition, we also don't have any security group, so let's create a one that can be used for other VMs as well. You can specify the name of Security Group Demo SG with its description. Firstly, we need SSH type for TCP protocol for port 22, and to make sure only I can access I have limited to my IP address, and we can add another rule to allow HTTP or HTTPs for port 80 to all source type to make internet access is routed properly via this port. Once security group is created, we can verify all the technical configuration before creating EC2 instance. To create one, click on Launch Instance. It will take few minutes to create instance, and another few minutes from pending status to running status. Now we can use our local PuTTY to SSH into our instance. But before that, we need to convert our private PIM into PPK key as it will be needed as private key to SSH into this instance. Here we can use our hostname that is EC2, user at our public IP address, which can be found on your instance details in your AWS console and can copy from there. Once you have put your hostname, you can select your converted PPK key and put it here in SSH and auth. Once you have done all these configurations, you can SSH into your instance and start working remotely. Let's create another EC2 instance that will be accessed via private subnet and routed via NAT gateway. We will further access this instance using Session Manager. You can keep any name for instance you wish to and can choose Linux 2 AMI. We will choose a low-cost T2.micro instance type here. For demo purpose, I will keep the same keys as we used in previous case. Here in networking, I will choose the VPC we created with choosing private subnet this time, and with the same security group we created for our previous instance. However, we will do SSH via Session Manager, but we need an IAM instance role. For IAM instance role, you can go to IAM and create an EC2 service execution role and attach this Amazon SSM managed instance core policy that is minimum required to SSH into EC2. After all these configurations, you can launch instance, and it should take few minutes to have instance in running state. Once instance is ready to connect, you should observe there is no public IP address this time, and we can connect using private IP address. Here you can connect into Session Manager where it should navigate you to your instance session just like you did with PuTTY and start working. You can try to ping internet and verify if you are getting any response or not. Here we are at our end of hands-on session on EC2. I hope you have enjoyed this video and learned some fundamental concepts. Thank you for watching this video, and don't forget to subscribe our CloudPulse channel.